I hope you can see my sharing. Are you able to see my sharing?
Yes.
Okay, so we're going to start Champ Electric, and I really like this chapter, Champ Electric, because it's very simple and there's nothing really which is complicated. So that's what we're going to start with. And actually, I even prepared some examples. Yeah, some examples. So will be like you do the code, also look at some examples, and like that. That's how we're going to move. So under Champ Electric, we're going to define definition and propriété. We're going to define what is champ electric, and also we're going to look at its properties. We're going to also look the topography to champ electric. What is its topography? When I say topography, is how is it presented? Like the diagram form, the diagram, yeah, how is it represented in the diagram form? Then then also going to look at champ créé par une distribution de charge continue. So here, when we talk about distribution de charge continue, we know we're talking about where you can find where the charges can be found almost anywhere, and we're going to look at the champ which is created by this distribution of charges continuum. Then we're also going to look at the champ créé par géométrie particulière. Yeah, and last but not the least, we're going to look at the symmetry and the invariance. Yeah. So the first thing is the definition and the properties of champ electric. So we're first going to define what is champ electric, and after that we're going to look at we're going to look at its properties. So when we define champ electric,
We put their black.
someone is making noise. Okay. Yeah. So we're going to define what is champ electric. So here, under my definition, champ électrique est une région de l'espace où on tout point un charge Q maintenant immobile et soumis à l'action d'une force électrique. So here they are saying champ électrique, it is a region of a space where in all point the charge Q, which is maintained immobile, is soumis, meaning is underput at the action of a force electric. So basically they're saying they are talking about the force. For example, if you remember, we talked about force in our previous lesson. So we know that when you are creating force, there is one charge or one particle which causes the force on the other, and the other receives that force. So here they're just talking about a champ électrique. It is a region de la space où on tout point un charge Q. So they're saying it is a region of a space where in all point a charge Q maintained, which is maintained like the charge Q which is not moving is put under the action of force electric. So here they're just saying that it's a region where one or I can say one charged particle is put under force. So here we're just going to calculate the champ electric in which this one charged particle is I can say is put, like the champ electric, we're going to, I can say champ, it means an area of something. So we're going to calculate the area which one particle is found, or the charged area in which this one particle is found, and this, I can say this one particle, I can say we're going to calculate the electric charge or the charge, we're going to calculate the area in which a particle is found, and this particle is charged by another charged particle. I think you understand this when we go to look at the diagram. So yeah, so basically when we're talking about the champ electric is basically calculating the I can say well calculating the force, which is we're only going to calculate the force for one charged particle, and this force is the force for a charged particle which is causing that force. We're going to calculate the force for a charged particle which is causing that force, because this charged particle is the one which is creating a champ electric. So we see here that a champ electric is caused by one particle, and this particle is the one which we're going to calculate its force, which is exerting on another charged particle. And for the another charged particle, basically we're not really going to consider its force, which it is I can say which it is reacting back. We want to consider its force. We're only going to consider the area which is created by one charge, the electric charge area which is created by one charge. So for this one, we can explain better if you the down part, which is in mécanique, les champs de personne et la champ qui exerce une force sur tout compte doute de masse M au voisinage de la Terre. So this one is not really important, but basically they're just talking about it. The champ de personne is just weight. This is weight, person is weight. So you know the formula for weight. Weight is equal to M, which is mass, times the gravitational force. Yeah, this one is common. So we're going to, I'm going to explain more on the champ electric, how it works. Yeah, so that to make the definition to be clear. So for champ electric, what you should know that is under champ electric, there's a charge appelé source du charge électrostatique. So there's a charge which is called what? Source du charge electrostatic. So there's a source where the I can say the force is coming from, which is called the source du charge champ electrostatic, meaning this source or this particle is the one which is creating an area which is what? Electric. Champ is a field or an area which is what? Electric. So here we're only going to consider a source which is creating what? A champ electric. So when you're talking about champ electric, you see an area which is an electric area which is created by a source, which I can say a source which is a particle which is charged. I can say so. So we have, for example, we have CO, which is situated on un point P. So I've got CO, which is the source to champ electrostatic. So when you see here CO, which is situated on point P, which is this point, the charge Q. So we have a CO, which is situated on port P, the charge Q. Then, soit une particule chargée C1. So we have another particle which is charged what? C1, which is situated on M, the charge Q1. So which is situated on M, the charge Q1. So we have got, I can say we have got two particles. There's one which is situated on P, which is C0. Then there's another one which is situated on M, which is C1. Then on note R is equal to PM, la distance entre la source et la charge C1. So R is the distance between the source, which is P, and the charge M. Yeah, the charge C1, which is what? Which is M, so you have PM. So the distance between these two is noted by R. Then on note UR, which is the vector, which is moving from, since this is the source, it's moving from 0 to 1. Le vecteur unitaire à l'air de la source à C1. So this is a vector unitaire which comes from the source to C1. So it comes from the source to what? C1. Du fait de la présence de la source, la particule C1 ressent une force. Of the fact of the presence of the source. So due to the fact of the presence of this source, which is P, the particle C1, it feels ressent une force. It feels the force. So here, when we're talking about champ electric, actually we are talking about the force which is created by one charged particle and which is filled by the another charged particle. So here, basically, what I can say is the same formula for, if you remember the formula for force, the formula for force is the formula for force is this one, which is Q1 times constant times Q divided by R squared UR. So here, Q1 and Q, they are charged particles. So if you notice closely, you see that under force, you calculate for the, like you include the two charged particles, the one which causes the force and the one which receives the force. That's what you include when you're calculating force. This is the formula for force. So you see that for the formula for champ electric is represented by E. What you do is you remove this one, which causes this one, which receives the force. For example, Q1 is here, which is Q1, the charge particle Q1 is point M, which feels the force. So for Q1, we're going to remove it. We're not going to include it, but we're only going to include the one which is causing the force, the one which is creating a champ electric, because this one P is the one which is influencing, or is the one which is, I can say, the source. This source, I can say a source is where something begins. We all know that a source is where something begins. So we know that it's from P where everything begins. It's P which causes the premier force. It's P which causes, I can say, it's P which causes the force, and M, it feels it, it receives it. So here we're only going to calculate for P, which is causing the force, which is creating this electric area, which this is champ electric, which is creating this champ electric, so that M can also be what? Be charged, or M can be moved to move outwards, inward, depending with the sign. So here we're only going to calculate the champ, the area which is electrically charged. So here, when you're talking about champ electric in simple terms, it's just calculating the force which is caused by the source. We don't include the force which another particle receives, but we only calculate the force which is caused by what? The source. That's why here you're seeing that we have only included for Q, which is the source. So for you to know which one is the source when you're calculating champ electric, your vector will direct you. So when you see that it is from 0 to 1, meaning you are starting from this side going to this side. Like most of the time, the vector directs you where the force is going. So first, for a sharp electric, what you should know is you have to find the source first. For you to calculate sharp electric, you have to know which one is the force. Then after you have known which one is the source, you can now write the formula for calculating the sharp electric. Then you do your calculations. You do your calculation. For force, the only difference between sharp electric and force is that force, you include the two charges, because when you're calculating force, you calculate the force which is caused, or the force which is transferred, and the force which is what received. So you calculate for the both charges, Q1 and Q, that's the force. But for sharp, we only calculate the force which is transferred. You only calculate the force which is caused by the source. So you have to see which one is your source. So I don't know if you are clear here, or you need some explanation. If you have any question, you can ask before I go to another page.
Can you just summarize everything up? My network was cutting.
Oh, okay. So here I'll just talking about in summary, I was just talking about the difference between force and sharp electric. So here, what you should know is that for sharp electric, you have to check for a source where this force is being caused. So what you should know is that for a sharp electric, you only calculate the force which is created by the source. So in this case, they have told us that the force is the source do sharp electric. So when I'm talking about the source, as I said earlier, is where it begins. So they have told us that the source of sharp electrostatic is on P, which means that it's P which is transferring the force, or is P which is what causing the force on point what M. So P is the source, and P, they have said that its charge is what? The grand Q, the capital Q, which is, this is the charge of P. So for me to calculate its sharp electric, I have just to write the formula, which is the similar formula for force, but I'm going to remove Q1. I'll just remain with it. K times Q divided by R squared UR. So the Q1, I'm going to remove it. Unlike for force, you include the Q1, you include the charge which is also affected, the charge which receives. So when you're calculating force, you calculate the force which is created between the two charges, the one which causes and the one which receives. But when you're calculating the sharp electric, you only calculate the force for the charge of the source, or the force for I can say the particle which is causing the force, the source to sharp electrostatic, the charge which is causing the force, and in this case, the charge which is causing the force is the capital Q. And for you to know which one is the source, so when you're calculating sharp electric, you have to see which one is the source and which one is not the source. So for you to know is your vector is always going to direct you. They are always going to direct you. For example, here they've said your vector is 0 to 1, and you know that it's moving from P to M. Yeah, from what? P to M, because they have specified for you, meaning they have specified for you that your vector is 0 to 1, le vector unitaire à l'aire de la source à C1. So they're saying it's moving from a source to C1. So basically, most of the time, you have to, before you answer this question, you have to check which one is the source. So basically, most of the time, the one which is the source is the one which is causing an effect on another charge. So you see which one is causing an effect on another charge. Then after identifying your source, you can now calculate your sharp. So I don't know if it's clear. The one who has some network problem. So this is the formula for sharp electric. This one you just have to know it by heart. So we know that K is the constant, which can be 9 times 10 to the power 9, or which can be 1 divided by 4 pi epsilon. So K, you just have to check for your previous school, the previous lesson. You see that we talked about this, the K, the word. So I don't know if it's clear to the one who asked me a question.
Yes.
Yeah, I don't know if there's anyone else who has another question. Yeah, so if there's no one, we're going to continue. So you have seen that it's just the same things like force, but the only difference is one calculate the force for one charge, which is causing the force, not which is feeding the force. So we're going to continue. So a champ électrostatique créé par une charge ponctuelle isolée. So I remember I talked about the charge ponctuelle isolée, which means this is a charge which is not distributed everywhere, but it's a charge which is fixed. You can only find it at once. So here they're just trying to explain to us more on what is champ electrostatic. So here, imagine you have got two charged particles. There's positive and the positive. So I'm going to start with this charged particle, which is here, the first one. So I want you to follow me. So I'm going to start with this charged particle. So you see that this charged particle, it will cause a force on this another charged particle. And this force, you see that this is the force which is this charged particle is causing, and it's moving in a vector what? 1 to 2. So so here you see, if you see here, there's force exercée par le charge Q1 sur le charge Q2. So this is Q1, this is Q2. So there's a force. Let's start with it. Q1. So we know that Q1 is exerting a force on Q2. So what happens? So when Q1 is exerting a force on Q2, the direction of this force is defined by a vector 1 to 2, meaning it's moving from Q1 to what? To Q2. So here, when you are calculating a force, I said when you're calculating a force, you have to calculate for the two charges, which is Q1 times Q2. So when you're calculating the force, this is a well-known formula which we know. You are going to calculate, when you're calculating the force, you are going to include the two charges, the one which is causing and the one which is receiving. So the one which is causing, which is exerting a force on Q2 is Q1. So we know that Q1 is the one which is exerting the force on Q2. So here you can say that our source is what? Q1, because it's the one which is causing a force on what? Q2. So when you're calculating your force is from 1 to 2. So this one is really important. You have to be showing where it is moving, because if you forget this vector, it means you don't know what you're calculating. Like, you confuse us. We don't know where this force, because the force can be exerted in two ways. So you have to be including to specify. So if you want, you can just write F1. I will know that it's moving from 1 to 2. Or you can include both of them, F1, 2. So meaning it's moving 1 to 2. So its force is K, which is 1 divided by 4 pi times epsilon times the two charges Q1, Q2 divided by R squared, 1 to 2, meaning the distance between between Q1 and Q2, then times the vector, which is 1 to 2, meaning is the direction in which the force is being exerted. So you see that Q2 is the one which feels the force. So here I'm going to remove Q2 outside, because it's the one which feels the force, and the Q1 is the one which exerts the force. So you see here that if I remove Q2, which feels the force, and I write this the same formula, just removing the Q2 outside, you see that this whole formula here, which has Q1, which is exerting the force, is just equal to champ electric. So this is where champ electric is being coined from. So that's what I'm saying. When you're calculating your champ electric, you have to know which one is the source. And according to the question, they will define or they will tell you which one is the source according to the way the vectors are moving. So it can be 1 to 2, you know that the force is Q1. If it's 2 to 1, you know that the source is Q2. So you have to be seeing the vectors. It's really important. So here you see that E1 is the Champ electric, the source, the force. So if the force which is caused by the force, then Q2 is the one which feels this force. So your E1 is just equals to the formula which is in brackets, 1 over 4 pi times epsilon times Q1 divided by R squared times the vector which is moving from 1 to 2. It's the same thing here. When the force is exerted by the charge Q2 through the charge Q1. So when the force is exerted by a charge Q2 on charge Q1. So when you exert a force Q2, when Q2 is the one exerting a force to what? Q1. So when Q2 is the one exerting a force to Q1, so even the vectors will change. That's why we have seen here, we have force 2 to 1 because Q2 is the one which is exerting the force on Q1. So here our source is what? Q2, and the Q1 is the one which feels this force. So we see here that when you're calculating the force, you include the two charges, which is Q1 and Q2. This is the formula, the well-known formula. Then you remove Q1 because Q1 is the one which feels the force. You remain with this one in brackets. So you see that this one represents the Champ electric. So F21 is equal to Q1 times Champ electric. Yeah, E, which is the formula for Champ electric. So you see that E2 is equal to 1 over 4, which is just this one, 4 pi times epsilon 0 times Q2 times R squared 2 to 1 times vector 2 to 1. Yeah, so this is how you, basically this is how you should know about the Champ electric. Yeah, basically, if you know what you are doing, if you know what you are looking for, you won't have any problems. If you know what am I looking for and what should I know for me to calculate a Champ electric? So what you should know simply more is, when you're calculating a Champ, you only use a charge which is exerting a force. So you see which charge is exerting a force according to the vectors. And here, you know, since it's positive, we have learned about this. If it's positive, when I exert a force from Q1 to Q2, you see that the Champ electric which will be created will be going outwards, and the force will be going outward because it will be like repelling, like they are separating because they are of the same charge. And this one, when Q2 exerts a force on Q1, the Champ electric will be going outside, and the force also will be going outside because you see, like separating, you see, there's repulsion which is taking place. So here they're just saying Q1, Q2 charge sources are the origin of the Champ electric. Q1, Q2 charge cible qui subisait l'effet du Champ electric. So here they're just saying it's the same thing which we explained here. They're just trying to explain that at first we had made Q1 to be at first we had made Q2 to be we have made Q1 to be a source. Then the second time we made Q2 to be a source. At first we had made Q2 to be the one which fuels. At second we made Q1 to be the one which fuels the force. I don't know if it's clear here. If you have any question, you can ask. Any questions? Anyone with any questions before we move on? Where you're not clear, ask. You should ask, please. Because when we move.
I have a question.
Yes.
So when it comes to the Champ electric, here we are seeing A2, and the other side it's E1. So is that showing the direction where it's going for the Q2 or what?
Yeah, actually, it's I can say it's showing the direction where it's going. When you say E1, meaning it's moving from like it's showing that this shampoo electric was created by Q1. Yeah, E1 it shows that it was created by Q1. E2 it shows that it was created by Q2. Yeah. So yeah, I can say like that. So when you are calculating your sum, when you just it's just the same thing. When you just put one, I can say one variable or one number which shows where it's beginning. So that's why I've seen they've just put E1, which shows that the beginning is the first, the sum is caused by Q1. Yeah. So E2, the sum is caused by Q2. So yeah, so this thing that they're just representing where it's caused. I don't know if it's clear. The source.
This is clear.
I don't know if there's anyone else with any question. So if there's no question, we're going to continue. So we're going to look at the additivité slash ou bien principe de superposition. So additivité ou bien principe de superposition. So additivité or principle of superposition. So when I talk about principle of superposition, I'm just talking about the addition of the champ electric. Imagine that there are different charged particles which are causing a force on one particle. This, for me to know its champ, I have to add the different I can say I have to add, for me to know each champ which is created on a certain point by a lot of charges. I have to calculate the champ for each charge first. After I calculate, I add them. So when I talk about additivity or principle of superposition, you just know that I'm talking about the addition of something, addition of. So there, like on force, we talked about the addition of force or forces where you can get force which is caused by each particles on a point, then you add them together. Then when we talk about additive of a champ, you calculate the different champ which is caused by these different white charge particles, and you add them together. For example, you have this point M, and you see that there is charge Q1 and charge negative Q2. So charge Q1 causes a force on point M, and charge negative Q2 causes a force on point what? Point M. So we have got two charges which are causing a force. So we have got two sources here. You have got two sources which are causing a force on what? Point M. So for me to calculate its champ electric, I have to calculate the champ for Q1, and I also have to calculate the champ for what? Charging negative what? Q2, because both of them are the sources. So I calculate each champ here, champ which is being caused, which is E1, since this one is positive, and imagine this one also is positive, because you have seen the charge E1 is going outside, meaning there was a repulsion, like there was something, they were separating. So it means this one positive, also the Q is what? The M, the point M is positive. So that's why I've seen the charge going outside. Then the champ going outside, sorry. Then here, negative Q2 and M, since this is negative charge, and we have said this one is positive, you see that the shampoo coming what inside this, like it's been there's an attraction which is taking place. So for me to calculate the shampoo total, I have to add this one plus this one. That's why that's where I can say the additive or the principle of the superposition comes in. So when we are talking about the principle of superposition, we're just talking about the addition of the champ electric for us to have our champ total, which is created only a certain point. So le champ créé par un chargé est la somme superposition des champs créés par chaque charge prise indépendamment des autres. So they're just saying that the champ which is created on the champ which is created by n charges is the sum of the champ created by each charge which is taken independent from each other. So here, that's the same thing which I was explaining. For you to calculate the champ total, you have to calculate for the champ for each charge independent. Then after that, you add them together. This is the phenomenon of superposition, the principle of superposition. I don't know if there's any question here before we move on. Is there any question under additivité and or bien principle de superposition? The champ electric. Is there any
What's
question?
that E without the number?
What?
The E without the number there on the diagram.
Is there an E without a number? Or the EI?
No, this side on the diagram. Yes. Between E1 and E2.
Oh yeah, this one.
Yes.
This one is
Yes.
the champ total which is created. This okay. I can say when you add this E1 and E2, you create a champ total. So you don't need to represent it with a number because it's the total of these two which is created. I don't know if you are getting me. You are clear. So when
yes,
yeah, they're just since it will create something like since when you try when you try extending this one which is prior to this one and this one which is prior to this one where they are meeting, that's where you create your champ total. So this one just represents the champ total. So you can either write it E total or just E, which you present the champ total. So we don't usually represent it with numbers. Yeah, I don't know if there's any other one. Any other question? So yeah, if there's none, we're going to continue with the, we're still on definition and propriety. So we have defined what champ electric is. We have seen some properties of champ electric. Now we're going to do an example on how can you calculate the champ electric in a diagram. So there was application 1, which I tried solving. Yeah, we're just going to look at it first. I tried solving this one. So application 1 says, déterminer le champ électrostatique créé par 3 charges ponctuels identiques Q greater than 0 placés au sommet du triangle équilatéral en son centre géométrique G. So here they're saying, déterminer le champ électrostatique, determine the champ électrostatique, which is created by 3 charges punctual identique. So which is created by 3 charges. So you have Q, 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 which are identical. So they're saying that these charges are identical and are greater than 0, meaning this Q is positive, this Q is positive, this Q is positive. So you have 3 charges which are identical. So there's the one on A, which is positive, positive, and positive. Placé au sommet du triangle. These are the things which I said, which is placed on the sommet. What is the word in English? The end of the triangle. I can just say the end of the triangle, the summit du triangle. So the end of the triangle, which is this end, and this end. So you have Q, Q, Q. And this triangle is equilateral. You know what an equilateral triangle is, right? an equilateral triangle is a triangle which has all its sides equal. So these things are really important for you to when you're solving this kind of question, you have to take each and every information really important. So we are talking about a triangle which is equilateral, which means it has all its sides to be equal on son centre géométrique G. So we have 3 points, which are A, B, C, which are charged positive Q, positive Q, positive Q, and which are causing a what? A force on a particle, which is what? G. So we have, so here, if the first thing which you have noticed that we have got 3 sources. We have got the source on A, we have got the source on B, we have got the source on C, which are causing a force on G. So for me to calculate its shamp electric, I have to calculate the shamp which is created by B, the shamp which is created on C, and the shamp which is created by what? By R. So I have to calculate this shamp. Then after that, here the principle of superposition comes in. The principle of additivity comes in. So I have to calculate each one of them and I add them together. And note also that there is the distance between A and B is R. So if the distance between A and B is R, it means B and C is what? R. It also means A and C is what? R, because you are playing with a triangle which is what? Equilateral. So here we have identified three. I can say we have identified some things on this triangle. We have identified that we have got 3 charges which are found on A, B, and C, and these charges are greater than 0, meaning they are positive. We have got Q on A, Q on B, and Q on C, because all of them, they are identical. And we have seen that these charges are causing a force on a particle G, which means that these 3 charges are the sources. And if they are the sources, we have to calculate their shamp, and after calculating their shamp, we have to add them. Then we'll find our shamp total. So here they're just we are just trying to find the shamp total. So now we're going to go to our calculation. So we have A, B, C, which is Q, Q, Q. Here I forgot to put the Q. So you have your E total. Your E total is equal to your EA, which is A, the shamp which is caused by A, by this point A, plus your EB, which is the shamp which is caused by this point B, plus your EC, which is the shamp which is caused by this point C, towards Z. So, which is, I'm just going to replace my EA, my EB, and my EC. My EA, since we have said that, according to the diagram here, the charges are Q, Q, Q. So here, I'll start with is E total is equal to Q divided by 4 epsilon E0 AG squared. So my AG squared, AG squared is the distance from here to the point where it's causing, which is G, this distance, which is my AG squared. Since we said R squared was the distance between 2 points, the distance between the causer and the receiver. So the distance is, we're going to, under this case, since it's coming from A, we're going to consider AG. So it will be AG squared times the vector, which is what? AG, which is moving from A to G, plus Q. Since on B also it was Q, so it will be plus Q divided by 4 pi epsilon 0 BG squared. Since the what is caused from B going to what? G, so the distance between this is a BG, so BG squared times vector UBG, because it's moving from B going to what? To G, plus Q, which is the charge which was here, is Q divided by 4 pi epsilon 0 CG squared. CG is the distance between C and the G squared, then vector UCG. So this is, you have written now your what? your formula. So when you come to electricity, you have to be what? You have to be familiar with this thing, because it's all about practicing. If you practice, you know how to go about this. So the first thing which we do here, you have your distance AG, BG, and the CG. So here I have to find their way, because AG, BG, CG, they don't really have a significance. It will be difficult for me to do calculation with just writing AG. I have to replace AG by its values. The AG, the BG, and the CG, I have to place it by its values. And in here, they have told us that the distance between A, B is what? A, which means that the distance between A, C is what? A also. Then the distance between AC is also what? A. So this one is really important to note. So here, you should know that if the distance of these sides are equal, which means that, and you see that the point G is on the center of this triangle, which means that the distance AG, CG, BG, they are all equal. The distance what? AG is equal to the distance BG is equal to the distance what? CG. This one you should what? This one you should do also note, because you are playing with an equilateral triangle which has all sides equal, and the point which the force is caused is on the middle, meaning all the distances between AG, BG, CG, they are all what? They are all equal. So if AG is equal to BG is equal to CG, if I know my AG or if I know my BG, then if I know my AG, it means I also know my BG, and it also means I also know my what? My CG. So how do you calculate? So the simplest one to calculate here is the simplest one to calculate here is what? Is the BG. The BG is simple to calculate here. Why I'm saying it's simple, if you see here, there's the distance BG is this here, and you have a line. This line is cutting in the middle. Yeah, due to my drawing is not to scale, so bear with me for that. So you have BG, this distance, then there's also this there's a line which is cutting in the middle, so meaning it will cut this, it will cut BC on the middle. So when you cut BC on the middle, which we have said that it has a distance of R, when you cut it on the middle, it means this side here will be R divided by 2, it will be half. This side also it will be half, so it will be R divided by 2, R divided by 2. So I'm going to calculate for BG. So BG, I know that the distance between B and C is R divided by the distance between B and G is R divided by 2, and G and C is also R divided by 2. So the G, I just brought in the G to facilitate the things. Yeah. So you have BG, which is R divided by 2, and you have the distance also. Since it's on the middle here, you know that the distance from the top here to down here is R. So since the G is on the middle, so it means it will be half, it will be also half, so it will be R divided by 2 also. So you have got the R divided by 2 here, and also the R divided by 2, and they want you to calculate the distance of hypotenuse. And you know, if you are given something like this, you just use the Pythagoras theorem. That's what you are going to use. So for you to find your BG, so it will be BG squared is equal to BJ squared plus JG squared. So your BJ squared is A over 2. Your JG squared is A over 2 also. So it will be A over 2 squared divided by 2 squared plus A squared divided by 2 squared plus A squared divided by 2 squared, which will be just if this, you know that this one will be 4, the denominator will be 4, which is here the 4. Then A squared plus A squared, it will give you 2A squared. Then if I simplify it, it will be A squared divided by what? 2. Then since I have BG squared, I will just square root it. square root it, I'll have BG is equal to A divided by square root of what? 2. So this is the BG. So if BG is A divided by square root of 2, it means AG also is A divided by square root of 2. It means CG also is A divided by square root of 2. So I don't know if you are clear on how to get AG, BG, and CG. If you are not, ask your question so that before we move to another step, we will forget about this one. Any questions? Are you clear?
Yeah, so where was the J coming from?
What?
Where is the J coming from?
Oh, I said that J, I just included the J here to facilitate the things. If you want to get, you can include any number. I will just, since I want to find my BG, so it means for me to find my BG, there was a line which is cutting on what? On the middle here. So this line, I just tried to extend it, and I found that there's a point here which is cutting between B and C. So I just decided to name the middle point to be J. But if you want, you can name it to be K, to be L, to be M. I'm just trying to simplify the things, or to simplify the calculation, because when you're calculating, when you want to find the distance BG, you use the Pythagoras theorem, and the Pythagoras theorem is this is hypotenuse, since this is the longest distance. So for you to find the longest distance, just this side squared plus this side squared. So I was just trying to simplify the things. I don't know if it's clear.
Yes.
Yeah, I was just trying to, for me, my main goal is finding BG, since it's the one which we have in our equation here, AG, BG, and the CG. Those are my main goal of finding. I don't know if there's anyone else with any question.
I have a question.
Yes.
Can you scroll back up where the diagram is, the one you drew?
Yes. Yes, you can.
What if instead of showing all that working, you do? Yeah, since there you have AG, which you know A from A to J there. What you have is A. So instead of working that out, what if you say, since that point we have in the middle two is our AG, which would be our
A divided
BG
by 2.
and our CG.
So also you
yes, because we know that that point is the middle. So
yeah, you are saying that you use AG and GC to calculate SC. You use AG and GC to calculate SC. If I'm getting you correctly.
no, what I'm saying is, since we know that from A they are going down, we have A, that's A, because it's a triangle, right?
Yeah.
Then we, from A to the middle there, we know it will be half, which is A over 2, which is one of the things we are looking for. AG is one of the things we are looking for. So instead of working it out, we know that AG will be half, which is A over 2.
Oh yeah.
Would that work? When you're working.
I don't think that one it will. I don't think it will work, because if you consider AG, there will be then I'm saying it's a bit complicated, because if you consider AG, you find that you write directly A over 2. You write directly A over 2, and that one it's since I've said that the diagram is not to scale. Yeah, since I've said the diagram is not to scale, so which means that for me to calculate my AG, here, there are some things which I have to consider, because this BG and AG, they are equal. So meaning this one is, I can say, how can I say it? It's not, it's not for small, how can I say it? It's not really, it's not really A over 2, this one, because this distance here, AG, is if you draw it under a diagram which is scaled, let me just take this diagram. Yeah, if you see here, if you see here the diagram which is scaled, you have seen the distance here. Have you seen the distance? It's like you are, yeah, this distance is too long to be half. So it's like you are what, you are somehow creating, if you see, you are creating a triangle which has a distance which is A, and yeah, a triangle which has a distance which is A, and the distance which you don't know. So this distance, you cut it in two. If you check here, if I cut it in two, so this distance here, since they assumed that is making a right angle, and they assume that this distance is half of what, of I can say is half of, how can I say it? You have made the distance AB, and there is AG and BG. These are equal distances, and they say that you have your R, which is this side, and you have your G, which is in the middle. When they say in the middle, meaning the distances which are AG and BG, they are equal. C and G, they are also equal, but the distance which is cutting in the middle of this circle, you see that it will be half, because it's on the center. The distance which is cutting in the middle of these two sides, it will be what, half, because the point is on the center. If you see here, this distance is logic that this distance is what, is half. So basically, most of the time is, if you go with AG, the direct one with AG, you find it to be more complicated, because for you just go direct to be, for it to be A over 2, but in the actual sense, it's not A over 2. You have to do the calculation, because the distance, actually, this distance is too long, and the distance down here is too long. So what is guiding us is on the middle. And if it's, it's on the middle, it means this line here is cutting the middle of S, and this line here, it will be cutting the middle. So basically, most of the time, for you to conclude that the distance from A to here will not be J. For you to conclude that the distance from A to J is equal, you have to to get a ruler. You try measuring this distance here. You try measuring, just for you to be sure, you try measuring this distance here, and you also try measuring the distance here, because most of the time the diagrams are to scale. So you see that the distance which is here to, let me say J, is equal to the distance which is here to J, to this point here. So so that one, actually, I wouldn't advise you to go directly, because the diagrams, you have to really be careful when you are calculating these things. You have to really be careful. Yeah, I don't know if I've made myself clear.
Yes, thank you.
Any other questions?
If you're saying AG is it's going to be longer, it's not equal to BG, but how is it that the final answer, it makes BG AG and SC equal?
I said AG, BG, and CG, they are of the equal size. And I was saying that I said that AG and for like I was answering the question which your friend asked. Your friend asked that is it just the same if I just calculate for AG, like I just since AG, she said that since AG is I can say is on the middle, so it just is it the same if I just write A over 2? So I said that one it won't be practical because your AG practically is more than half. If you check here, it's long, it's more than half. And if you also check the BG is more than half, the CG is more than half. So I was just trying to explain to her that it won't be logic for you. It won't be logic for her to just go direct with the AG, but all the distances they are equal. The BG, the AG, the CG, they are equal. But the only thing is that when you are calculating, you have to be careful because you have to be careful in calculating because the point here, like the point here, is I can say is not really I can say if you check the triangle which is made here, the triangle which is made like which are in the dotted line, you see that the distances here is not equal to the distances which are inside here. And when you see the point here, you have to consider that this point here is quite all right for me to find the point here, which is on the center, but it's drawn in terms of what vectors. You should know this one. It's drawn in the terms of vectors. So at this point here, if you extend it, it will basically cut on the middle. If you extend the point here, it will cut on the middle. And if you extend the point here, it will cut on the middle. But where this point here, it is here, is not, how can I explain it? It's not on the middle to say so. It's on the vector which are cutting, is the ones that which are cutting what? Which are cutting on the middle. Yeah, so you see that the distances AG, BG, and the CG, they're not automatically half. You have to know how to calculate it because it's like you are creating a triangle inside, and that triangle, you have to calculate its hypotenuse. I don't know if I'm clear.
Yeah.
Yeah, so basically these things you just have to I can say when these things you have to like you just have to get familiar with them. And yeah, and basically you have when you're calculating these things, you have to put in mind I can say the vectors. You have to put in mind the vectors. Where is the vector cutting? You see that this vector is cutting on the middle. It's cutting, all of it is cutting what? On the middle. And you have also to, if for example, for me to calculate BG, you have to see, for example, you have to see what is it creating inside of this triangle equilateral. So for me, I observe that there is a right angle triangle which is created inside here. There's a right angle triangle which is created inside here. So for me to determine the distance here, so since the distance here, I want really, I can say I want to really know it. So if I know this distance here and I measure this distance here, if I see that the distances are equal, it means if this one is half, it means also this one is what? Half. Then I can calculate my BG. Yeah, and yeah, I don't know if there's any other question.
I have a question.
Mm-hmm.
So from what you're just from saying, it's like you're saying the distance from okay, wait, can you go to the diagram that you drew?
Mm-hmm.
So it's like you're saying the distance from B to J and the distance from G to J are the same?
The distance from what?
From B to J and from G to J are the same.
Yeah, that's what I'm saying. The distance to you are the same, and yeah, the distance from B to J and J to G are the same. Then
Could you
also
explain how they're the same?
I want also to clear this one. I think I'd made an error. If you have seen the distance A to G is like you are traversing a route. The distance A to G for I can say is A to this is G here. This one you have to get correct. You have to get it. The distance A to G is not what it's not. It's I can say since you are traversing on the middle here, like you are the A is moving from A to J, not G. Sorry, A to J. You are traversing on the middle. The distance which is in between here is not for small r. Yes, you have a question. The one who had the.
I was saying, can you explain how the distance from G to J is A over 2?
The distance from what?
From the point G to J, like how is it A over 2?
That's why I said that for you to know it, you have to I can say it's a matter of I can say it's a matter of probability. For you to know it, you have first to know the distance between B and J. So how do you know it? So you know that when this vector ER cuts in the middle here, it will divide BC into the two distances, A over 2, A over 2. So basically, since this is a drawing which is to scale, what you can do if you try to get your ruler, you measure the distance BJ and measure also the distance GJ, you find that they are of the same distance, they are equal. You find that this distance they are equal. And the other thing is, if you see here, is what is kind of making a right angle. It's like the vector here is in other terms, the vector here which is coming here is making a right angle. And you know that when a right angle is made, the distance which are in sides are equal to the distance which you are the distance which in the sides are equal. Basically, the distance which where the 90 degrees is being made. So you know that this distance here is equal to this distance here. Basically, most of the time when you should go back on the right angles. You should go back on right angles. When you check on the right angles, you see that those which make right angles basically they have got the same distances. Yeah, those if the secondary word, if you check just read on right angle. So you see here that you have a right angle, and a right angle most of the time, if you don't need to measure all those things, where a right angle is formed, you should know that the sides which make the right angle, they are always equal. So just the same thing here. You have got this right angle which is made. So you should know that this side is always equal to the other side. So if this side is A over 2, it means this side is A over 2. If you're not sure, you can use a ruler, you measure, then you find that it's just equal. I don't know if I'm clear. Is that?
Yes, you are.
Yeah, so the right angle, like what you should know just is right angle triangles, where the right angle is formed is always equal, like the what are equal. So yeah, that's what you should know. And you should also note that the distance AJ is not equal to R. You should note that the distance AJ is not equal to R. But since is this one, the point G is on the center of the triangle, it means the distances here, they are what? They are the BG, the AG, the AG, and the CG, they are equal, but they are not equal to A. That's why we are forced to calculate the distances BG, AG, and the CG, because we don't know what are they equal to, because this distance AG is really a short distance. As compared to the side ones. I don't know if I'm clear there. Any questions? Yeah, so if there are no questions, so you have found your BG, which is equal to AG, and which is equal to what? To CG. So now, how do? You just replace it where there is BG. So your BG, it was here it was AG squared, BG squared, and the CG squared. So you just have to replace here. So it will be, if you replace this one, if you replace, it will be A squared divided by 2 UAG plus 4 pi epsilon S squared divided by 2 plus Q 4 pi epsilon S squared divided by 2. Then when you do your mathematics, you know that when this is, you are dividing a fraction, and when you're dividing a fraction, the one which is down goes on top, the one which is on top goes down. So you have Q2 4 pi epsilon 0 A2 UAG plus Q2 4 pi epsilon 0 A2 UBG plus Q2 4 pi epsilon A2 UCG. Then 2 cancel out with 4, 2 cancel out with 4, 2 cancel out with 4. So you have Q divided by 2 pi epsilon 0 S squared UAG plus Q divided by 2 pi epsilon 0 S squared UBG plus Q divided by 2 pi epsilon E0 S squared UCG. Yeah, then you see that you have got things which are in common. There's Q divided by 2 pi epsilon A2 S squared, Q divided by 2 pi epsilon S squared, Q divided by 2 pi epsilon S squared. So we have things which are common. So we just take this outside the brackets. Then you have UIG plus UBG plus UCG. These are the vectors. So I don't know if I'm clear until there. Do you have any questions?
I have a question. How is it A squared over 2 when the final answer is A over square root of 2?
Which one?
The BG.
Mm-hmm.
In the final answer, A over square root of 2. Yes. But we're using A squared over 2.
If you square the whole thing, here, if you have seen I've squared the whole thing, A squared over 2. So if I square the whole thing, it's just meaning I'm squaring the A on top and I'm squaring the 2 down here. So if I square the A, you know that it's A squared. So the square root will cancel out with the squared. The square root will cancel out with the squared, which will give me A divided by, if I square the 2, we don't know the square root of 2. Like if you square 2, it will give you maybe 1.000 or 1 point something, which we don't know. So I'll just leave it in what? In square 2. That's why I've said A divided by square 2. I don't know if it's clear.
Yes, but this value that we found, isn't it the same one we're going to use in the equation here?
The one A squared divided by 2?
Yes.
Yeah, it's the same one which we're going to use, but here I just broke it down so that you see what your BG is. You see the distance BG, what BG is. So here I broke it down so that I calculate the distance what BG, so that I show that if you see here the AG, the BG, and the CG is equal to A divided by a square root of 2, which means that the whole distance, the A to J distance, the B to here I can name it K distance, the C to I can name it Z distance, they are not equal to R. So here they are just showing us that these distances which on the middle, I have to know this distance BG. That's why I've just broken it down, like down to the actual BG, the distance, to know it. I don't know if you are clear. The one who asked the question? Hello?
Okay. Okay.
Yeah. Yeah. So basically, if you don't want to waste time, you can just leave it here, then you do your mathematics, because you are just replacing our main goal is finding the BG squared, all those things. You can just leave it here on S squared divided by 2 if you want. If you don't want to go to BG, there is nothing wrong with that, because you are just trying to calculate the E total. So
Explain
now,
again how the Q went up.
the what?
Explain again how. So kindly explain again how the 2 went up and the A squared remained down.
Oh, okay. For the 2, since you are dividing S squared divided by what? By is Q divided by S squared divided by 2. You know that when you are dividing a fraction, when you just the same as when you are dividing a fraction, just the same as when you are multiplying it, the denominator becomes the numerator, and the numerator becomes the denominator. So you see here that Q is divided by S squared divided by Q is divided by S squared divided by 2. So we see here that for me to find the answer for this one, I have to multiply Q times 2 divided by S squared. I think you know those mathematics. So you see that the 2 will go on top, and the A squared will come down. This is that's the mathematics which I just did. So basically, you should just try, like you write it on side of the paper, then just try doing the calculation. You see that if you are dividing, if you move it from division to, for you to find the answer, you have to move it from division to multiplication. So when you move it to multiplication side, the 2 will come on top, and the S squared will come down. I don't know if I'm clear on that.
No, yes, thank
you. Okay. So now, so now you have what? We have found an expression for the distances, which are CG, BG, and AG. So this one, we are done with this one. Now we have got the problem with the vectors. How do you calculate the vectors? So what you should know, under Chimbi electric, we also play with the vectors. But for the force, basically most of the time the vectors, you don't play with them. But for Chimbi electric, you have to play with the vectors. You have to solve the vectors. So now you have got the vectors which are remaining, which we have to play with. How do you go about them? So when it comes to vectors, you see that there are different vectors which are created. You see that there's edge here. So the force which is caused by A on G, it creates a vector which is UAG, which is the one which is going outward. So here you have seen that actually the G and the A, they are of the same one, they are of the same sign, because there is like a repulsion which is taking place, and you are creating a vector which is going outside according to according to our diagram here, there's a vector which is going outside, and going outside. So there's a vector which is created by A, which is going outside. There's a vector which is created by C, which is going outside. There's also a vector which is created by B, which is what? Going outside here. So it leads us to conclude that the sign between this point G and the sides, the end of the sides, they are equal. So you have got for A, which is the vector UAG. You have got for B, which is this vector UBG. You have got for C, which is this vector UCG. So how now do you calculate the vector? So this one you have to get me clearly. So when it comes in, you finding the formula for each vector, you have to note the plan in which you are dealing in. For example, this plan, since it's not a 3D, you are dealing in a X or Y plan. That's why I've written Y and X here. If you have seen, there's Y and X here. So since this is a plan form, it's not in 3D. So I'm dealing with the X or Y plan. Yeah, you have to know the plan. And also you have to know the angles which are created by each vector. You have to know the angles which are created by each vector. So since we have said that it's an equilateral triangle, if I cut in the middle of an equilateral triangle, for an equilateral triangle, you know that a triangle, basically it has to have the total angle of 180. You know, I think you know that one. The angle which are inside, they have to be 180. And you know that for you to have 180, it means you have to have 60, 60, and 60 here. So if you have 60, 60, 60, and if you cut in the middle here, it means the angle which you have cut here is what? The angle which is in the middle here is what? 30 degrees. So here we are moving with the X and the Y axis. So here it's just the same as I can say there's what? It's just the same as you have cut in the middle of the what? The X and the Y axis. This line here is just the same as you have cut in the middle of the X and the Y axis. And since this one is making a 360 degrees, it will be what? The angle which will be created is what? A 30 degrees. And if you remember, I said the angles here we represent angles in pi. So we know that 2 pi is equal to 360. What of 30 degrees is equal to what? We don't know. So the 30 degrees is just equal to pi over 6. So this one is really important for you to note. So you have to know the angles which are created before you calculate your vectors. You also have to know in which plan am I working? Is it the X or Y or the 3D, the X, Y, Z? You have to know in which one are you working in. So here we're working in X or Y. So first of all, we're going to calculate for the vector HG. So how do you calculate for the vector HG? So for you to calculate the vector HG, you have to know that if you have seen the X and Y, the way they move, the Y it moves, it has an arrow which is going upward, and when you're going upward, basically you have positive numbers. Then the X has got an arrow which is going sideways, which is towards the right, and when it's going towards the right, you know that you have positive numbers according to your number line or what, you know that you've got a positive what number. So how do you calculate your vector UG? So your vector UG, so your vector UG.
Before we move on, on the E total, why is it 4 pi? But in the previous part, we found the 2 pi EA epsilon 0.
If you remember in my previous lessons, we said that you should know this by heart, that 2 pi is always equal to 360. If you remember correctly, I said 2 pi is always equal to 360. Pi is equal to 180. So if I want, I can use pi is equal to 180, then x is equal to 30 degrees. Then I do my cross multiplication, it will still give me pi over 6. So you can use either two of them. You can use pi is equal to 180 or 2 pi is equal to 360. These are the things which you should know. And I said here in Morocco, when you are representing the angles, you don't represent them in the degrees like form, like 360 degree, 30 degree, 40 degree, 20 degree. No, you present them in form of what? Pies. That's why I said I had to change the 30 degrees to a pi first. So how do I change the 30 degrees to a pi since I don't know what pi is represented? So if I want, I would have used pi is equal to 180. I don't know what 30 degrees represents. Yes?
I understand how we found the 30 there. I'm talking about there on the formula, the E total there, the
Which
Q
one?
over 4 pi on E total on the left.
Oh, yeah.
You know, before we moved.
Or Q
Yeah,
over.
we found.
No. Here
Yeah.
is just a small error. Here is supposed to be 2.
Yes.
Yeah, it's supposed to be 2. I think
Okay.
you remember you had found 2 that side, right?
Yes.
Yeah, it's just a small error. It's supposed to be 2.
Oh, all right.
Mm-hmm. So yeah, so here now we're going to find our AG and our BG. So how do you find your AG and your BG? So this one you also have to know how to find it. So I said, first of all, you have to know in which plan are you working in for you to find these vectors. You have to know what angles are being made, and you have to calculate it in the pi form. And you have to, then from there, you have now to have the next step, which we are going to do right now. You have to be able to define some steps, which we are going to do. So here we're going to change the vector AG in terms of x and y. The vector AG in terms of vector ux and uy, because we are working in the what? In the plane form. That's where now the coordinate Cartesian, the what, those things, they come in. So those things are really important. So you have your vector UAG. How do you do it? So your vector UAG is this line here. And if you have seen this line here, it's like, how can I say? It's like you have your XY, there's a straight line. This is the line AG, the AG. So when you see this line AG, is it making an angle? It's not making an angle. If you view it in terms of, so when you're solving this, you have to be viewing it in terms of the X or Y plan. So here you have to view it in terms of what? The X or Y plan. So there's AG, this line here, which is making a vector AG. There's AG, which is making a vector UAG. So this AG is a straight line. And when a straight line is a vertical straight line, which means it's representing the Y vector. So if it's representing the Y vector, which is a vector straight line, you see here that there's this line, it doesn't make an angle, it doesn't open. It's like it's coming direct, like it's coming direct here. It's not making an angle, it's not opening or making an angle. So you see here there that there's no angle which is made. That's why you have seen that AVU. And you see here that it's only moving what? Vertically. It's only moving what? Vertical, not in the x-axis, not in this, I can say not in the x-axis, the right side or the y side, but it's just moving what? Vertical. So when it's moving vertically, you should know that your x-axis is 0, toujours, always. Your x-axis will present what? Is 0, meaning there's no x-axis because it's only moving in what? The line is only represented in what? In the y-axis. And in the y-axis, you have to see how is it moving. Is it moving up Is it moving down or is it going up? So if we see going down, meaning it's going opposite of this arrow. And when it's going opposite of this arrow, we have said that when you are going up, it's positive, but when you are coming down, which is this vector here, which is coming down, which is opposite, it means it will be the negative. So it will be negative uy. So just 0 ux, which will just give us 0, then negative uy. So we have represented it in terms of uy. So first of all, you have to see in terms of the x or y, is it making an angle? If it's not making an angle, if it's a vertical line, if it's a straight vertical line, you should know that there's no angle which is made there, and it's moving on in the what? Y-axis. This one just have to have it in your head. It's moving in the what? Y-axis. And in which direction is it moving? Is it down or up? If it's moving down, you should know that it's opposite of the vector uy. So if it's the opposite, it means it will be negative uy. So it's just the same where ux, you don't include it, you just remove it, then just write it negative uy. Then I don't know if it's clear there. Is it clear? Hello?
Yes.
Yeah. Then now you go to vector bg. Vector bg, ubg. So ubg is this one, ubg. This vector ubg. So if you have seen here, this is the line which is making 30 degrees. So I'll get this line, I'll write it here, in the middle here. So you see here that the angle still be the same, the 30 degrees angle, but you see that it will make a sort of a what? Of a triangle. If I get this line the way it is, it's going this side, it will make a sort of a triangle. So how do you end this? You should know that the angle is what? 30 degrees. The angle is always the angle you have here. So how do you do it? So you have your x and your y. So your x, you know that your x, if imagine you have drawn a line here, which is making an angle with the x-axis. So meaning your x become your adjusted, then the vector ubg, it becomes hypotenuse. And you know that if it's adjacent and hypotenuse, you know that you have cos, so katoa, you have your cos. So your x is just equal to what? To cos. That's why here I've written what? Cos. Then the angle, you have to know what the angle is it? 360, which is pi over 6 ux plus, since the angle is made with an x, is not made with y, which makes y the distance which is going up, the opposite, you know, is so, which is sine. So which makes y is equal to what? To sine. If I don't know if you remember the thing we should do. So this is the sine pi over 6 uy. So you should always know that the other thing which you should know is when you are making an angle, what you should know under the Chimbi electric, when you're making an angle, the x-axis is always cos. Then the y-axis is always sine. This one just have to know, they never change. Because the angle, basically, most of the time, the angle is made on the line between the hypotenuse and the x-axis. So the x-axis is always cos. The angle which is made between the x-axis is always cos, and the angle which is made, the angle which is made with the x-axis, it becomes cos, and where the side where the angle doesn't touch, it is sine. So this one you have to know. Then you just in this angle, just place the angle which is 30 degrees, which is just equal to pi over 6. Then you do your calculation to find your BG. And also you should know here, you should also know here there's this line, which is this is the line which you are drawing here. And if you have seen this vector is going towards the right side, and it's like going upward. So it's going towards the right side, if you see this vector, and it's going towards upward. So meaning it's going in the direction of the y-axis, and it's going in the direction of the what? The x-axis. So which means that the cos and the sine will be, both of them will be what? Positive. Meaning I want to write negative cos or negative sine. I like the CG, you see the CG, why the negative came in and why there was the positive. So here, when you do cos pi, if you punch on your calculator, you find cos pi over 6 is equal to square root 3 over 2 ux plus sine pi over 6, you find that it's 1 over 2 uy. So this is your answer when you punch in the calculator. So this one, you got it, you put it aside, then you now calculate your CG. So your CG, as I said earlier, your CG, you have seen that your CG is CG, the vector is going this side, like it's going the other side, the other way around. So instead of going like this, it's going the other side like this. So here you see that is quite all right. The CG is going up, but it's going from the right side, going to the left side, meaning the x-axis is going opposite from the direction of the x-axis, which is the negative side. Is going towards what? The negative what? Side, the CG. That's why here you've seen I've written negative cos pi divided by 6ux plus sine because it's always a positive sign because it's always going what? Upwards. The CG is always what? Going upwards, which is the positive side. So that's why I've said positive sign pi over 6, where positive sign is just the same as half, and this one is just the same as negative square root 3 over 2 ux. I don't know if it's clear up to there. So I bring in the uy and the ux. Is it clear? Hello?
Explain why we've used sine.
What?
Okay, explain why we've used sine.
Okay, yeah, I said you are calculating, for example, you are calculating BG, and I said, no, you are calculating BG. So BG is this one here. You have seen that there's an angle which is being made here between BG and the BC. So if I get this line here, so basically when you are calculating for the vectors, you have to get the line which is making the vector and you place it on the y-x plane. So when you place it on the y-x plane, you see that quite all right, there will be a 30 degrees angle. So you see that it will cut the y-x plane. It will cut the y-x plane, and you have the 30 degrees the other side. So this 30 degrees now you have to if you remember under Cartesian, you have to find a way of calculating now your vector UBG, which is formed this vector which you draw here. Since here we are going to you get this line which is the vector, so I have to calculate your UBG. So for me to calculate my UBG, it means that since UBG it represents the hypotenuse, I'll make a triangle. I'll make a sort of a triangle. So you see that there is an angle which is made here, and this angle is made between the hypotenuse and the x. So which means that where the angle touches, it becomes the adjacent. The side where the angle touches, it becomes the adjacent. And if you know your SOHCAHTOA, car is adjacent over hypotenuse. So here, just the same as your here, since here is supposed to be since it's touching your x, it means your x will be equal to what? Cos. And this cos, you have been given the angle which is pi over 6, the 30 degrees. So it will be cos pi over 6 ux because it's been defined by the angle is touching what? X. So I said you should just know that most of the time when you have ux is cos, then when you have x, where there's x is cos, and where there's y is sine. That's what you should know. And the sine is because if you see here, the angle is touching only the x, but the y-axis, the angle is not touching the y-axis, which is in the side here. That's why it will become the side where there's y-axis, it will become opposite. Since we are calculating for hypotenuse and the opposite, so it's so if you use the SOHCAHTOA, it's under so sine is equal to opposite over hypotenuse. That's why we have used what? Sine here. But toujours, always, the x-axis is defined by cos and the y-axis is defined by sine. The only thing which changes here, you see, where is this line going? So you have to know the direction where it's going. So here you have seen that it's going upwards. It's going upwards and towards the right. And if you see here, the y-axis is also, the arrow is going upwards, and the arrow, the x-axis, the arrow is going what? Towards the right. So you see that this one is in the same direction as the y and the x. That's why I've just written positive cos pi over 6 ux plus sine pi over 6 uy, because both of them are positive. But in the case of CG, CG is the opposite, where you see that quarter right, the vector is going towards up, which is the same as the y-axis, which is the upward, but it's going in the opposite of x-axis, which is going towards what? The left. That's why I've seen that where there's the x-axis, I've put negative cos because it's going the opposite direction. I'm just showing that it's going the opposite direction. Plus, I'll put plus where there's the y-axis because it's going in the same direction there. The vector, my vector in the diagram. So that's why I've put negative and positive. So the cos and the sine, for ux, you should always know that it's cos, and for ui is sine. I don't know if I'm clear there. Am I clear?
Yes. Yes. Yes.
Then even for this one, for y, I've just gotten the urg. I'll just get this line, the straight line. This is a straight line. This line, I'll get it, and when I place it under my xy, you see that this line is just coming direct here. Like this is the line, and you see that it's not making any angle. There's no angle which is being made here. It's just a straight line, which is vertical, and this line is coming downward. That's why I just have to write it negative uy, because there's no angle which is here, and it is moving in the direction which is opposite to y. That's why I've just written negative uy. This one you can forget it. If you want to, don't even write it, because when you multiply 0 times ux, it will always give you 0. Yeah, so it's negative uy. So now when you have found your UAG, your UBG, and your UCG, you now replace with your equation, your what here. So here, yeah, here is supposed to be 2, supposed to be 2u, supposed to be 2. I think I was really fast. I had to forget I put 4. So now you replace with the URG, UBG, and the UCG. URG, UBG, and the UCG. You have to replace here. So you have your URG, which is so for this one, instead of what, yeah, you can start. So for me, I started with my UBG and the UCG. So you can start with any which you want. So my yeah, I started with my UBG and my UCG. So here, when I was replacing, I just went directly grouping the like terms together. Since you have seen here, there's UX, there's also UX. For UCG, I have UX. For UBG, there's UX. For UCG, there's UX. For UBG, there's UI. For UCG, there's UI, and also for UAG, there's what? UI. So I just had to put them together, to group them together. So I started with the UX. UX we have under UBG. Under UBG, I have square root 3 over 2 UX, which I wrote here, square root 3 over 2 UX minus, this minus is coming from the UX, which is negative. So negative square root 3 divided by 2, which is under UCG, which is this one. And you know that when you subtract this one, it will just give you 0, plus half UY, which is for UCG, plus half UY, which is for UBG, minus UY, which is for AG. Then you know that this one also will give me 0. So you see that the total charge, it will lead us to what? 0. Everything will lead us to 0. And this is, I can say this is logic, because you have got sides which are the same, you have got the charges which are equal, and when these charges, they meet each other, they cancel each other, and you have a charge total which is equal to 0. I don't know if it's clear till there. Is it clear?
Yeah.
Yes.
Yeah. So here, note that when here on you should know that there's two. We had found two. I think it was just some small area when I was really fast when solving this one. So here you should know that you should put what two. So for this one, base card you have to get familiar with it. The angles, the what, in which plan you are working in, which angle have you formed, what. You have to know that, for example, a square, each side has 90 degrees angle and all that. Then when you divide it, all those things, you have to, a triangle, correct? A triangle side is 60. If you divide it, then you'll be so first of all, if you see here, first of all, the most important thing, what you should note is, how are you coming up with the answers, your formulas? In electricity, most of the time, they really look at it, how you are solving. The answer, can be not correct, but if you have used the right method of solving, if you have followed the right steps of solving, you will get the marks. You get the marks because electricity is very involving. Like you have to do a lot of calculations, and sometimes it happens that you don't even finish during the exam. Don't even finish, but you have solved. You have just left it somewhere. So what you should know first is you have to, when you are calculating the Champ electric, what you should know is, first of all, you have to deal with the distance. After you have dealt with the distance, you have now to go to the next step is, after you have dealt with the distance, you have to go to the vectors. And after you have dealt with the vectors, you have now to, after I've dealt with the vectors, then that's also here is dealing with the thing which you should know. First of all, you have to deal with the distances, which is between, and after dealing with the distances, you have to deal with what? The vector. And you should also know that where there is a right angle triangle, always the sides, if you know one side where this right angle is touching, is always equal to the other side. So these are the things which you have to know. And because most of the time you'll be found with it. You'll be found drawing. Like most of the time you find that they're basically most of the time they're right angle triangle, which you'll be using most of the time you'll be using the Pythagoras theorem. So if you know this rule, you won't have any difficulties. I don't know if I'm clear on that one. Is there any question? Another question? So this is the example. You have seen there's a lot of things. So this is so I'll say for today we'll end here. I'll end here for today. Then we'll continue on Wednesday. On Tuesday, I heard there's an inauguration on Tuesday. Is it true or what?
It's true, but no one is going there. Only invited guests.
Oh, okay. We'll see. But I'll think about it. Since I don't know, some of you want to watch it. You want to watch it, but I will inform you by the end of the day how it will be, if you have class on Tuesday tomorrow or not. Okay, then have a nice day and enjoy the rest of your lessons.
Thank you. Same to you.
Thank you.